So in this video, I'm going to talk specifically about the tangent line problem. In the process of doing that, what I'm hoping you guys are going to get out of this is knowing some of the history behind calculus. The fact that, calculus didn't just, spring up out of nowhere. There was a lot that built up to it. I'd also like for you to understand the difference between a tangent line and a secant line, and that's what I'm going to go over first. And I'd also like at the end to kind of draw some connections between what we've been doing before, which is talking about limits and how limits lead us into what is actually considered the calculus. So what I'm going to do first, like I said, is talk about secant lines and tangent lines. So just to kind of give you a brief idea, a secant line is what you see over here on the left. If I have that blue kind of thick curve, the secant line is that dotted line that connects 2 points on that curve together. And remember, lines keep on going forever, so it extends past that. So one of the ways, I'm going to mention this more in a second, is you can think that this secant line actually cuts through the curve. It's always going to touch the curve in more than one place. That is opposed to the tangent line, which you should see over here on the right. It is the same exact blue curve. However, if you notice in this case, the tangent line is just barely touching the blue curve. And so in this case, I realize that that blue curve is going to kind of oscillate. It's going to go back and forth. And eventually it may touch in another location. But the whole purpose of that tangent line, and I want you to pay attention to it, is that it follows, I'm going to use the word the slope, it follows the slant of the original curve. It kind of has that, I'm going to use the word instantaneousness to it, where it looks like it just sort of glances off or just barely lightly touches the curve in that one location. And it's specifically in that one location. We're only looking at what's nearby. Same kind of idea with when we were talking about limits, we talked about neighborhoods. So now that I've kind of given you the idea of the difference between a secant line that touches in two places versus a tangent line which is supposed to touch in one place, we can talk about how this kind of developed as a problem in history. So I'm going to start off with Euclid, who is considered the father of geometry. We don't have a specific date for him. We just know he was around 300 BC. He did write the first, what we would consider set of geometry books, or even reality, math books in general, called Euclid's Elements. They were 13 really long, big books that just kind of collected all of mathematics up at that time. He was an ancient Greek mathematician, and he gave one of the first definitions of the tangent line. It was actually in the third book of the 13. Which he said, a straight line is said to touch a circle which, meeting the circle and being produced, does not cut the circle. So in this case, he was describing a tangent line to a circle. So you may remember in geometry talking about tangent lines and circles. In this situation, this kind of presented the idea, and this is what held for quite a long time, that if I draw a circle and I want a line tangent to the circle, it has to be perpendicular to a radius at that point. And, this is, again, the very first kind of definition, the very first instance we ever see tangent lines ever really appear, historically speaking. Now, the question becomes, what were they using it for? Well, Euclid was specifically talking about math, but other people in history were using tangent lines to describe the motion of something that's been launched or thrown, some kind of projectile. Other people, and I'll mention later, were using it to describe the bending of light through reflections and refractions. They were trying to work with glasses and lenses and things like that. There's lots of instances where tangent lines are actually particularly helpful. Specifically in physics is a great place that we see them. They're a great thing to talk about when we talk about rates of change, which we're going to get into later. Another person, also ancient Greek, was Archimedes, who lived from about 287 BC to 212 BC. He spent a lot of time talking about spirals and a lot of other different types of math, and he extended the idea of tangents past circles and also tried to construct tangent lines to his namesake spiral. He actually has a spiral called the Archimedean spiral. So he's expanding the idea of tangents beyond just, touching a circle to touching really any curve. And that's really where this problem kind of stems from, is the tangent line problem that's beginning to develop here is, how do we construct a line tangent to just any curve, not just a circle, but any curve that I ever want to look at. And so there are, at this time, early 200s BC, we were seeing a lot of new kinds of shapes, conchoids, cissoids, spirals, lots of different kinds of curves. And, we were looking for ways of creating tangent lines to those things. Continuing on this line, we also have Apollonius of Perga, or also known as Apollonius the First. He was around 240 to 190 BC. He was known specifically for his work with conic sections, which are parabolas, hyperbolas, and ellipses. And circles were the other conic section, but those aren't, we had already talked about those. He was really, again, extending the idea of what a tangent line was, and he really kind of brought this method of finding tangent lines a lot further, because he was finding tangent lines to parabolas, to hyperbolas, and to ellipses, and he actually found concrete, consistent ways for creating them repeatedly. So, we have these new kinds of curves, and he's doing a great job of working with tangent lines with them, but, there's still a lot of other curves to talk about. Now, people continue to work on this problem for quite a while longer, but it's not going to get any real, I'm going to say, huge leaps, huge jumps in change until we get into the 1600s. So, we're going from 200 BC to 1600 AD. So we're skipping several, about 1800 years. We're jumping forward in history, in the future. And I'm going to start with Gilles Poissonnière de Robivol. I'm probably mispronouncing that name. He is French. That's important. But important thing to know about him is he kind of revamps the definition of tangent lines into a much more understandable method, and one that really kind of drove how we're going to define it within calculus. So I know this is a really long definitions, but basically what he says was, by means of the specific properties of the curved line, examine the various movements made by the point which describes it at the location where you wish to draw the tangent line, and you look at all of these movements and compose them into a single one, draw the line in the direction of the composed movement, and you will have the tangent of the curved line. So he's basically saying, if you look at the areas around this point that you're looking for, and you try to figure out, and he's using the word movements to describe slope, if you look at all these slopes around your point, then you can try to find one that's about average of the others and draw a line through it in that direction along that slope, and there you have your tangent line. Now, I'm going to keep going because there are, some really big important people coming up, and one of them is Rene Descartes, who is another French gentleman who's from 1596 to 1650, so about the same time period as Robivol. But he's best known for the coordinate plane. He's kind of the guy that revolutionized geometry at the time, because no one had really thought about putting it on a graph. No one had ever thought about combining a grid system with it. It was all very, very loose, and it wasn't done with a lot of equations. Rene Descartes is kind of the guy who revolutionized that idea. And his contribution, not only to geometry, but to kind of the development of the calculus here, is that he was devising a method for constructing tangent lines using circles. Now, the only downside of that was his method was extremely complicated. And it was very, very obscure, and it took a lot of work, and it wasn't really good at certain places on curves like maximums and minimums. It wasn't good for handling those situations. But Rene Descartes did spend a lot of time talking about tangent lines, and he thought it was probably one of the most interesting problems that could be done in geometry, not just one that he was working on, but just in general. He thought it was a really interesting question, which leads us into the next person who also lived in the early 1600s, which is Pierre de Fermat. He presented the idea that later becomes the actual solution, although what he was using there was specifically similar triangles. He was constructing smaller and smaller triangles to find tangent lines and using that idea of slope along a triangle to make it work. However, this isn't quite exactly what we're going to do in calculus, because we have Isaac Newton, Gottfried Leibniz who come next, who, as you notice, these are early 1600s. Gottfried Leibniz and Isaac Newton were kind of 1660 was around the area, so kind of in the later half of the 1600s. That's when they invented the calculus, and we start to see the methods that we're going to use. They didn't have limits at the time. Limits didn't come around for another 150 years, but this is kind of the idea that they presented is what I'm going to talk about next, where we connect limits to tangent lines. So both of these gentlemen kind of came up with the idea of, hey, what happens if I start off with a secant line? I draw this line that connects two dots. Hopefully you guys can see this over here. I'm starting on the left, where the two dots are kind of farther away. And what I'm going to do is, if I want to find that point of tangency, the point on the left, I'm going to take the point on the right, and I'm going to slowly move it towards the point that I want to find the tangent line. So you notice I've got, 3 more pictures. And as I look from left to right, that point kind of moves closer toward the specific tangent line that I want to find. And that's essentially what we're going to do, is we're going to take the limit as one point approaches another, and we're going to turn a secant line into a tangent line, and that's how we're going to essentially develop this methodology. And this is essentially what Isaac Newton and Gottfried Leibniz were working on when they developed the calculus. Hopefully this does kind of explain to you a little bit more about just the history of calculus, where this stuff comes from, and how we're going to approach this process. Good luck to you, and I'll see you in the next video.